Okay, yeah, so I'm Matt Hawkyard. I'm a research associate here at Oregon State University, out at the Hatfield Marine Science Center. I work in the Newport Aquaculture Lab, and large majority of my work is focused on finfish, both nutrition and disease. So I'm really interested in finfish aquaculture because in the United States, we have really great sustainable fisheries, but most of those fisheries have reached their maximum sustainable yield. So most of the seafood that we eat as Americans, the vast majority of that are finfish species. So to increase that domestic supply of finfish to meet the demands of the future, this is going to be a really important area for us to grow in and create a sustainable aquaculture industry here domestically, preferably here on the West Coast, as there's a lot of opportunity in the marine environment to do so. So I'm really focused on marine finfish species, and that aquaculture, those methods can be done both onshore in what are called recirculating aquaculture systems. These are land-based tank systems that can be used to grow marine fish at a very high density. You can also do this offshore in offshore aquaculture. These are big cages that can be done well offshore and therefore having a minimal impact on nearshore environments. And so these are emergent technologies, but to be able to support those types of aquaculture, it takes a seed supply. So what we need is to get the fish from egg, and these marine fish typically lay very, very small eggs, oftentimes around the size of a grain of sand, a little bit bigger, but you can imagine these are among the smallest vertebrates on Earth. So this is a marine fish larvae here. This is it just happens to be a rock sole larvae. But this one's probably around 6 millimeters in length, which is very, very short. You generally need to look at them under a microscope to observe them. And to get them through this early stage is really important and really challenging because, as I said, they're very, very small. There's millions of them in a given batch of young. And what we need to do is keep them keep the environment healthy for them, so high water quality, those sorts of things, but also nutrition. They eat very, very small things, so they're nearly microscopic, and the things they eat are microscopic, and that makes it very challenging. And so what I do is actually work a lot in how do we feed these smallest fish to provide seed to support a domestic sustainable seafood industry. So I've done that through a couple ways. One is to actually look at what kind of zooplankton, these are the little microscopic organisms that the fish larvae eat. How do we actually improve the nutritional quality of these zooplankton? How do you grow them better? How do you maybe feed those animals to feed the fish? I know that's a little nuanced, but the other thing we've done is actually develop some microparticles here in the laboratory, so that we call these complex particles. And so these are actually kind of designer fish feeds. And the important things about these is they're very good at retaining water-soluble compounds. They can be tailored to meet a variety of different needs. But one of the things we're using these complex particles for is evaluating their use for oral delivery of vaccines. So disease is also a big problem in finfish aquaculture. And so what we're hoping to do is eliminate the need, or at least very much have a reduction on the use of antibiotics in marine aquaculture by having very economical and easy ways of delivering vaccines to finfish. So we're developing improved nutrition for the animals and also improved ways of dealing with disease in finfish aquaculture. And yeah, so hopefully our research goes well and we end up moving forward and moving the needle in a positive direction for having a domestic seafood or domestic aquaculture finfish industry.